20-foot ladder that's always the same. So it is against a house. There's a beautiful house with a 20-foot ladder. So there's our pretty house. There's our ladder. Of course, if you put your ladder not well placed against your house, or if you have perfectly slippery siding, then your ladder might start to slip, which is not a good thing. And that's the case here. Right now, it is sliding away from the house, and it's moving at a rate of 2 feet per second this way. We want to find out how fast it's going down exactly at the time where it is 12 feet from the house. So now I'm going to draw that exact time that it's 12 here and 20 here. We're going to assume our house is not the Leaning Tower of Pisa. Usually when they include houses, they assume that they're 90-degree houses, not wonky ones. So what do we know? Right, so if we start labeling things here as this is our x, this is our y, okay? We know that we want to find dy dt. That's what we've been asked to find. So we know that y is a function of time. We know that dx dt is going to be 2. And I'm going to say it's a positive 2 because if you think about the bottom, is the bottom increasing or decreasing? As it slides away from the house, that value on the bottom is going to be increasing. So this dx dt needs to be a positive 2 because of that. And that tells us that x is a function of time as well. Now we've got a right-angled triangle, so we can set up our relationship. We know that x squared plus y squared, this case, is always equal to 20 squared because the 20 stays constant. So there's no z in this one because we know that that hypotenuse is always 20. Now we can do implicit differentiation, so we're going to get 2x dx dt plus 2y dy dt equals 0. What will y be? Because we know x is going to be 12. We never did write what y would equal when x is 12, but we could figure that out. Favorite triangle of the day, 3, 4, 5. Dx dt was 2. So this will be 2448, 32 dy dt is equal to negative 48. And divide, you'll get is that right? Divide by 16, yeah. Negative 3 over 2. And we are dealing with, our units are feet per second. So it's going down at 1.5 feet per second at that moment.